I'm Hannah and this is Sarah, and we are volunteers with Let's Talk Science at the University of Victoria. Today we're going to be talking about acids, bases, and indicators.
pH is a measure of how many dissolved hydrogen ions are in a solution on a scale from 0 to 14. A neutral pH is 7, which happens when there's no extra hydrogen ions floating around and none are missing. Distilled water has a pH of 7. If the pH is lower than that, we say the solution is acidic. If the pH is greater than 7, we say it's basic. When scientists were first discovering acids and bases, they used their senses to determine the qualities of the solutions. Acidic solutions usually taste sour, whereas basic solutions taste bitter.
One of the most important safety rules in a modern chemistry lab is that you can't eat or drink anything. Even if it's something you think is safe, there can be dangerous chemicals around, so snacks and drinks have to wait until we clean up the workspace and wash our hands. None of the solutions we're using today will hurt us if they get on our clothes or skin, but if you're using any strong chemicals or cleaners to do an experiment, you should wear gloves and safety glasses to protect your skin and eyes.
Indicators are used to show a change in pH. They change their color as the solution's pH changes, which can tell us whether a solution is acidic or basic. This red cabbage is going to be our indicator today, and we're going to make a cabbage smoothie with distilled water. See how this cabbage juice is purple? Make sure you remember this color, because as you'll see later, when we add other things to it, it's going to change colors. Here are the items that we're going to test today. We have lemon juice, laundry soap, vinegar, baking soda, and tap water. For each one, we want to see whether it's an acid or a base, and how strong it is.
We're going to do the first test with lemon juice. Remember when we talked about the tastes of acids and bases? We know that lemon juice tastes sour, so is it an acid or a base? Lemon juice has a pH of about 2, which means it's a strong acid. Let's see what color it turns.
Now let's try the laundry soap. Laundry soap has a pH of about 10, which means it's basic.
When you eat vinegar potato chips, it tastes sour, right? That is from acetic acid on the chips, which tastes sour when it reacts with the water in your saliva. The color changed to pink, so where should this beaker go? We said that the lemon juice was an acid, and the vinegar solution is a similar color, which tells us that the vinegar is also an acid, and it should go on the lower end of the pH scale. However, it's a little bit closer to purple than the lemon juice, so it's a weaker acid. Baking soda has a pH of 9, which is in between neutral and the laundry soap, which had a pH of 10. That tells us that the color should be somewhere in between purple and the color of the laundry soap.
This time we're going to use tap water. When we made the indicator, we used distilled water because the minerals in tap water usually make it a little bit acidic or a little bit basic. Distilled water is only water without any minerals. So now let's test this. See how it changed color just a little bit? What do you think that means? Is our tap water a little bit acidic or a little bit basic? It looks like it's slightly acidic because the solution became a little bit lighter. Now we have a beautiful rainbow, and you can see how the different solutions change the color of the indicator, from our strongest acid to our strongest base.
If you want to test some more solutions, make sure you ask an adult for permission and help. Here's what you will need. Thanks for watching! We hope you had fun and learned a little bit about the world around us.